Hi everyone, welcome back to the channel. If you are preparing for the CCNA certification or just want to sharpen your networking skills, then you are in the right place. In this video, I have compiled all my CCNA labs from basic router setup to advanced OSPF, VLANs, access control list and even NAT configuration. Whether you are a beginner or need a quick refresher, this is your ultimate hands-on guide. I have also included the Packet Tracer lab files in the Google Drive link in the description below so you can download, practice and follow along. Make sure to watch till the end. This video will help you master CCNA labs and get hands-on experience for real-world networking. If you find this useful, hit the like button, subscribe for more networking content, and let me know in the comments which lab you found the most challenging. Let's get started. Hi everyone and welcome to the Cisco Packet Tracer lab series. Today is the lab 1 in this series. In this lab we will perform multiple tasks. In the task 1 we will introduce the Packet Tracer, its different menus, the workspace, etc. In task 2 we will add different devices to the workspace including a router, a switch, 2 PCs and a laptop. In task 3, we will study different connection types that are available to us in Cisco Packet Tracer. For example, the copper straight-through connection that is used to connect different devices. For example, connecting a PC to a switch, copper crossover connection that is used to connect similar devices. For example, connecting a PC to another PC. And again, the console, fiber, serial, and wireless connection types. In task 4, we will connect different devices inside the workspace. For example, we will connect PC1, PC2 and laptop to switch 1 and then we will connect the switch to the router. In task 5 and the last task, we will assign IP addresses to different devices. We will assign IP addresses to the PC1, PC2 and the laptop, and finally we will ping the PC2 from PC1. So let's get started with the task. So the task 1 is the introduction to the Packet Tracer. The Packet Tracer is basically a Cisco network simulation tool that can be used for designing, configuring, and troubleshooting networks. So here we can see that it has different interfaces. The top one is the menu bar, which has different types of menus available to us, including the file, edit, option, view, tool, extension, and windows. And we will study these in detail in the upcoming lab series. The second one is the toolbar, where we can see we have different buttons available and some of the same tasks that we can perform through the menu bar can also be done through this taskbar through these buttons. For example, if you want to create new topology or want to open an existing topology or save this topology, we can use this button. Again, these button, the copy, paste, undo, redo, zoom in, zoom out or zoom reset. These are important button and we will use them in the course of our lab series. The next next bar here is the drawing, or you can say, I think this one is the drawing palette. So in this one we have different tools. For example, this selection tool, if you want to select something, you can use this tool, and once selected you can use this button, the cross one, to delete them. This is an inspect button that can use to inspect different devices, when we will use once we add devices to the workspace. Again, this one is for writing notes. I have used this button to write these notes. This is used to draw a line, and these are button are used to draw different objects such as rectangle or ellipse, etc. So coming to the bottom of our window, we have this important toolbar, you can say here, the device selection toolbar. Here we can see that we have different buttons available to us. The first one and important one is the network devices. So inside the network devices, then we have multiple categories of the devices. For example, the first one is the routers. And in the routers, again, we have multiple models of the router available to us. Second one is the switches. Inside the switches, again, we have multiple model of the Cisco switches. Then the hub. Inside the wireless, we have multiple wireless devices available. In security, we have the security devices or firewalls available to us. And the last one is the WAN simulation, which we will use when required. The next important button is of the AND devices. And the first one is the AND devices in the category. And inside the AND devices, we have different AND user devices such as PCs, laptops, server, etc. available to us. And again, the next one is the components. And inside the component, we have these different boards or different transistor, etc. available to us. And the next important button is of the connections. And then inside the connection, we have these different connection available to us. This one is the automatic connection. If you want to use this tool, it will connect devices automatically without selecting the connection type. Then we have the copper straight to connection, copper cross or fiber phone connection, coaxial, and etc. So that's the brief introduction of this Cisco Packet Tracer interface. And during the course of our lab series, we will explore all these in detail once they are used inside our labs. The second task is adding devices to the workspace. So let's suppose we want to add these devices to the workspace. So it is done over here. First, we want to add a router. So we will come to the network devices. Inside network devices, we will select the category of routers. And then we are adding the router 2911. So we will select the respective router model 2911. Next is the switch. We will add a switch 2960. So we will select the switch category and we will add the switch 2960 to the workspace. Remember, this whole area is known as the workspace. And the next is the user end devices. We will select the user end devices and add two PCs, PC1, another PC, PC2, and a laptop to the workspace. This is a laptop. So this task is done. So it is simple and straightforward. You select the device category, such as the network devices. Inside the network devices, you select the specific category and then the specific model. So we are done with this task. The next, our task number 3 is the different connection types that are available to us inside the packet tracer. So this is available here with this sign. And in this, we can see that we have this automatic. So this one is basically the console. This one is the console connection type. The next is the copper straight through. Next is the copper crossover and fiber and so on. Also available to us is the, where is the wireless? So this one is the automatic connection selection. And we will see the wireless is not visible over here, but we will see it in a while. And the next task, or task number 4, is connecting these devices to each other. So we will connect PC1 to switch 1. And which connection type we will use? Remember, when using different devices, we will use the copper straight through. We can always use the automatic connect option, but here we will use the copper straight through, and we have these different interfaces available to us. Of course, we will use the fast Ethernet interface, which is the network interface available inside the network card of our PC, or which is the network interface. And on the switch, let's start from the beginning. We will select the interface fast Ethernet 0, 1. And the next one is we will connect the PC2 to switch 1. Again, we will use the copper straight through, and again we will select the fast Ethernet 0 of the PC2 and connect it to the second interface fast Ethernet 02 of the switch. And next is we will connect the laptop to the switch. Again, we will use the copper straight to connection. Let me this time use the automatic connection type, so that this is the automatic choose connection type. So it has automatically connected the laptop, and here it has connected the switch port number fast Ethernet 03. And the last connection is connecting the switch to router. Again, we can use the copper straight through, or we can use the automatic connection type. Let me choose the copper straight through. So I will use the fast Ethernet 04 on the switch. Remember, this is a 24 port switch, and inside the router we have three network interfaces available to us: gigabit Ethernet 0/0, 0/1, and 0/2. We will select the first interface. So we are done with connecting the devices to each other. So important points to remember here is that to connect different devices to each other, we will use the copper straight through, or we can use the automatically choose connection type. So here we can see that the connections, the green symbol show that these ports are on, they are connected. But here we are seeing that the router interface is showing the red symbol, which means that the port is down. And this is because inside the router, so another important thing is that if you hover your mouse over the device, it will show the interfaces that are available inside the devices and the interfaces that are connected. As we can see, the top three interfaces of the switch are up. The fourth one, which is connected to the router, is down because on the router side, you need to manually up the interface. Let me do it. We will go through these configuration detail uh, in the future labs in detail, but for now I just want to show you how to make this port green or make this port up. So I will go to the specific interface of the router, which is gigabit 0/0, and I will use the command no shutdown, because all the interfaces of the router are by default in shutdown mode. I will close this router CLI, and we can see that interface is now up. So this is the task number 4. Task number 5 is assigning IP addresses to PCs and the laptop. So now we will assign these IP addresses to our PCs and laptop. And once you click on any of these devices, it brings up this configuration windows. So inside the PC, we will go to configuration, and we will go to that specific, this is global configuration, you can say, where you can define the DNS server and the default gateway for IPv4 as well as for IPv6. But here we want to give the IP address to its interface, fast Ethernet 0, which is connected to the switch. So I will give the IPv4 IP address 192.168.1.1 and the subnet mask is 255.255.255.0. I will close this dialog box. I will go to PC2, configuration, fast Ethernet 0 interface, and I will assign IP address 192.168.1.2, and again the subnet mask would be the same. Now I will go to the laptop and it has the same configuration interface, and I will assign IP address 192.168 and 1.3 and the same subnet mask. And the last task is to ping PC2 from PC1. So I will go to PC1 configuration dialog box again. I will go to the desktop, and here we have different icons, different configuration items available to us. Since I want to ping, I will go to the command prompt. This is the same as the CMD inside our Windows PC and laptops. And I will type ping 192.168.1.2. PC2 IP is 1.2. Ensure it is accessible, it is pinging. I can also ping the laptop IP which is 1.3. Ensure it is also pingable. So I will close this dialog box, and this is it for this lab. I hope it has been informative. I will add this packet tracer file inside the description for you to download. So please subscribe and like the video if you liked it, and subscribe it so that you see the notification of the upcoming lab videos. Thank you and see you in the next video. Hi everyone, and welcome to the lab 2 of our Cisco CCNA lab series. And today lab is about basic router configuration, and we will perform the following tasks in this lab. Task 1 will be accessing different CLI modes inside the router. Task 2 is setting the router hostname. In task 3, we will be setting different types of passwords on the router. And in the task 4, we will be viewing different type of configuration as well as saving the configuration on the router. And the last task would be setting the banner on the router or a banner message on the router. So let's get started with the task 1. So first of all, let me select a router. Again, we will come to the network devices router, and let me select this one, 2911. So let me first change the router name over here. The name can be easily changed. You can just click on the name and then you can rename it. So the first task is accessing different CLI mode. So inside Packet Tracer, we will click on the router, and here we can see the CLI. And once you click the CLI, the router opts the user whether if you want to run the initial configuration wizard. We will write no because we will manually want to configure the router setting. So now coming to different CLI modes, the first one is the user executive mode. So this one, the default mode when you first enter the router CLI is known as the user executive mode. And in this mode, you have limited commands, basically limited to basic monitoring such as the show command. You can show different things such as R, CDP, clock, etc. And another useful command is regarding the monitoring that you can use the ping command over here. So this is the user executive mode. This is the first and the default mode. The next one is the privileged executive mode. Right over here, privileged executive mode. And in order to go to the privileged executive mode, we write the enable command. So you can write the complete enable, you can just write the en and enter. So now we are in the privileged executive mode. So in the privileged executive mode, we can do advanced monitoring and troubleshooting. For example, here we can see the current running configuration. As we can view all the configuration that is currently running on the router. So this mode that is shown with the in the form of this hash is known as privileged executive mode, where you can do advanced troubleshooting as well as monitoring. And the third one is the global configuration mode. And in order to enter the global configuration mode, we write the command configure terminal. So you can write the complete, or you can simply write the conf t as well. So now we are in the global configuration mode, and in global configuration mode, we configure the global setting on the router, such as setting the password, setting the host name, etc. So now we are done with the task one. The default one where you first enter the CLI is the user executive mode. Then the next one that is visible with this hash only is the privileged executive mode. And the third one that is used for global configuration is the global configuration mode, by inside which you can enter by entering the command configure terminal. So let's move forward to the next task, that is setting the router hostname. And this is since a global setting, so this configuration can be done inside the global configuration mode, and we are already inside the global configuration mode. And setting the host name is very simple. You just type the host name. So remember, inside the router, Cisco routers or Cisco switches, you just write few of the alphabets, and then you press tab key on your keyboard. The command is completed. So you write the host name and then the desired host name that you want to give to the router. In our case, we will give the name R1 to the router. So as we can see, as soon as we enter the command, the name is changed to the R1 from the router. So we are done with the task one, the host name, task two, the host name is changed. Now coming to the task three, which is setting the different passwords. So we will setting with the console password, enable password, VTI password, and at the end, how to encrypt the password. So we will do these one by one. First of all, setting the console password, and again this is done in the global configuration mode. So we are already in the global configuration mode. So how to set the console password? It can be set by writing line console and 0 and then enter. So now we are inside the console line configuration, and here we will type the password and our desired password. For example, we want to set the password to as Cisco123. Then we will enter, and at the last we will login, use the login command, so as this password is used at the login to the through the console. So now our console password is set. So let me demonstrate that this password is actually set. So So remember, the console is when you the console connection is when you connect to the router directly through your PC through the console port. So let me connect to this PC through a console port. I will drag a PC over here, and inside the connection I will select the console. So this is console. I will select the PC. This is RS232 is the serial console connection. I will select this. On the router, I will select the console. So now I am connected to the PC over the console. So I click on the PC to go to the console uh, configuration or to connect to the router to the console, and inside the desktop, this terminal is used to connect to the router to the console. These are the settings. So the default setting are good. So I will press OK, and now I am connected to the router through the console. Since I was already logged in, let me log out and log out from this as well. Now when I enter, now when I am entering the console, it is requiring the password that I entered or that I set, that is Cisco 123. And so the console password is set as we did in our configuration. Now I will close this. Now moving on to the next, setting the enable password. So this is the password which is required when you enter the privilege executive mode. So now I am in the user executive mode. When I set the enable password, it will require the password when I enter the enable mode or the privileged executive mode. So again, this password is set inside the global configuration mode, and it can be set by the enable password command. Enable password and the password that you want to set. So I want to set the password Cisco 123. So this password is now set. And remember, the enable password can be set in two ways: enable password as well as enable secret. And what is the difference between these two? I will explain in a while. I will keep this password as Cisco 123 as well and enter. Okay, so it is requiring that my enable password and my secret password should be different. So let me just keep it to as Cisco. So I will set the enable secret password as Cisco. So now this is set, and I will explain the difference between the enable password and the enable secret in a while. The next password that we will be setting is the VTY password, which is the remote access password. This is the password that you are required to enter when you want to access the router remotely over the network. So how to set the VTY password? Again, we will be in the global configuration mode, and inside I will write the command line VTY 0 and 4. So this is the command to enter into the VTY configuration setting, and inside this setting we will enter the password, and again our password Cisco 123, and at the end login. So now whenever we access the router over the network, we will need to enter this password. So another important thing is that now the next task is, and this is very important, is to encrypt the password. So now let me show you the configuration. Show running configuration. And as you can see, our enable password, it is in clear text, as well as our console password it is also in clear text, and our remote access password, VTI password, is also in clear text. So how to encrypt this password, because this is critical that our password are encrypted and they are not compromised during shoulder surfing, or when we save the configuration somewhere, these passwords are not visible. So again, we will go to the global configuration mode, and to encrypt the password, we are doing this task, encrypting the password. We will write the command service password encryption and enter. So this command will do the trick. It will encrypt all the passwords. So now let me get back, and again, as we can see, now our enable password is encrypted, as well as our console and our VTOI password. So remember, I was talking about the difference between the secret password, enable secret password, and enable password. So the enable password is the weak password, and it is stored in clear text by default. This 7 number basically shows the type of hashing and encryption used to save the password. So this is a weak encryption method, and it has been long compromised, while the secret password, enable password, uses MD5. The 5 number basically shows the MD5 hashing, and it is more secure as compared to the 7, which is an old encryption method and has long been compromised. So that's the difference. So when you are enabling the enable password, you should always use the enable secret. And when you use both of these, the router will enable this one. This one is overwritten. So when we go to the enable prompt and the password is required, we will need to enter this one. If we enter this one, we won't be able to go to the privilege executive mode. So let's go to the next task, and that is task number 4. And our task number 4 is viewing and saving the configuration. So as you saw, I multiple times view the running configuration. So what is the difference between running and startup configuration? So running configuration is the configuration that is currently running on the router, and it may not have been currently saved to the NVRAM. It is not currently saved to the memory that is existing, or that is uh, available through the reboots. So now if I reboot the router, all of my configuration will be lost because it is only running configuration. If I view the startup configuration is that is available when you restart the router. So there is no startup configuration. Why? Because we installed, or we made this available, a new brand router. So once I now the next task is the saving the configuration. So let me save the configuration, and you can save the configuration using 2 methods. First is copy. Sorry, this has to be done in the user in the privilege executive mode. So copy running configuration to startup configuration. So this will save all these running configuration as a startup configuration. So it is asking about file name, and I just entered, so it saved it as a default file name. The second command to save the configuration is the write memory command. It also does the same thing. So now if I want to view the startup, now the startup and the running configuration is same because I saved the running configuration as the startup configuration through this command. The command itself is self-explanatory. It is saying that copy my running configuration as a startup configuration. So now if I reboot the router, or if the power goes off, this configuration, my configuration will be saved. It won't be erased. So the next task is, or task number 5 is setting a banner message. So this is the message that is visible to user when the user logs in. And again, this will be done in the global configuration mode. So let me enter the global configuration mode, and it can be done as banner and MOTD. MOTD means message of the day. And here you can use any character, but I will use the hash. And after the hash, my message will start. Let's suppose unauthorized logins are not allowed. And I will enter the hash again to mark the end of the message. Enter. Let me save this configuration. Write memory. And now when I enter the router, it will pop up this message. As we can see, unauthorized logins are not allowed. So let me enter the console password. Again, I have to enter the privilege executive mode password as well. Okay, so that's all about today lab. I hope it has been informative. I will save this packet tracer file uh, inside my Google Drive and give the link inside the description so that you can download it. And another useful bonus point for today lab is that using this button, you can see all the commands that have been entered. So this is very useful tool. You can go line the history and see the commands that you have entered. So that's all for today. So please subscribe and stay tuned for the upcoming lab video, and see you in the next video. Thank you and bye. Welcome to the lab 3 VLAN configuration. So this lab is going to be very informative and interesting. So stay till the end of the video. And the tasks that we will be doing in this video are as such. Task 1 would be the introduction to VLAN. In the task 2, we will see the default configuration of the switch and the default VLANs. In the task 3, we will create different VLANs and assign names to the VLANs. And in the task 4, we will assign different ports to the created VLANs. And we will also perform some tests such as pinging different devices from each other. So let's start with the task 1, that is VLAN. What is a VLAN and why we need a VLAN? So when we install a switch in a factory default setting and connect our devices to it through Cat6 or Cat7 cables, this is simply known as a LAN, local area network. But we need more than just plugging cables inside the switch. Sometimes we need to create different logical segregation among our devices. And when we create these logical distribution, these are known as virtual LANs, because now inside the same LAN we are creating logical areas. That's why they are known as VLANs. Although overall this is a same one LAN, but inside this one LAN we are now creating multiple virtual LANs. And what is the need for the VLANs, or what are the benefits of the VLAN? So there are multiple benefits of VLAN. The number one is the security. So for example, this is our one department. Let's suppose this is the IT department. This is another department. This is, let's suppose, the HR department or the accounting department. And we want to limit access of traffic inside these geographical areas so that traffic of PC2 or PC1 is not visible to these IT guys and vice versa. So by creating VLANs and assigning these PCs to one VLAN and these laptop to another VLAN, we can create this segregation and limit the visibility of traffic between these VLANs. So in this way, it provides a limited security. The next benefit is the network efficiency. So when the switch is in the default configuration and when all the devices are connected to the same VLAN, the default VLAN, then the traffic of each device is visible to each other, such that when, let's suppose, laptop 1 want to ping the laptop 2, it does it through an ARP mechanism. Let's suppose laptop 1 knows the IP address of laptop 2, but it does not know the MAC address of laptop 2. So it sends an ARP request through the switch, and the switch then sends the ARP request to all its ports. Although laptop is only communicating with laptop 2, but all the devices that are connected to this switch are receiving the ARP request, and in this way a broadcast congestion is created. But when we create VLANs and the laptop 1 and laptop 2 are one VLAN and these devices are another VLAN, then the broadcast is limited to only this VLAN. These PCs do not see the ARP request of laptop 1 anymore. So in this way, network traffic efficiency is improved because unnecessary broadcast traffic is not sent to unintended devices. We can also say that by creating VLANs, we are creating multiple broadcast domains. So now we have two broadcast domain, 1 and 2. And the next benefit of VLAN is the ease of management. So of course, when we assign VLAN to different devices, let's suppose this is IT department. Now we can easily manage these devices. We can assign different policies to these devices based on the VLAN. And if we want to, let's suppose, share a printer among these guys, we can also do this through these VLAN setting and configuration. So that's the benefit, and that is the task one. The next task is now to show the default switch configuration. That what is when we just take the switch out of the box and see it, what is the default configuration of the VLAN. So let me just show it to you. We'll go to the CLI, we'll go to the privilege executive mode, and we will show VLAN brief. So this command will show us the default VLAN. So as we can see, we have these default VLAN 1, and we have all the ports of the switch in this default VLAN, that is VLAN 1. So these 1002, 1003, these are legacy VLAN, for example, token ring and fiber token ring, etc. These are no longer used, but they are available inside the switch. We are dealing basically with this Ethernet VLAN 1. So by default, all the ports of the switch are in the same VLAN, that is VLAN 1. And now let's do a test. We will ping PC1 from PC2 and also ping same PC1 from laptop 1. So these are the IP addresses that I have already assigned to these devices. It is basically the same network. So let me ping PC1 from PC2. So the PC1 IP there is a typo. Sorry, let me correct this. This is PC2. Now we are good to go. So the PC1 IP is, I will ping PC1 ping n.1.1.1. Ensure it is pinging. Now let me ping. Let's suppose I want to ping laptop 1 from PC2, and laptop 1 IP is n.1.1.3. It is also pingable, and .4 is also pingable. So I hope you get the idea. Since all these devices are in the same VLAN, that is VLAN 1, and they are also in the same subnet or same network, so they are able to ping each other. So now let's go to the task number 3. We will now create two VLANs. This VLAN yellow and VLAN green. We will name this as the HR and this one as the IT, because IT guys have the laptop, they move around. So now let's create the VLANs. Again, we will go to the switch. And as we saw, currently we have only one VLAN, that is default VLAN 1. Ignore this because these are legacy VLANs and they are no longer used. So to create VLAN, we will go to the global configuration mode, and creating VLAN is simple. You will just write VLAN and then the VLAN ID. So first we will create VLAN 100, and we will name this VLAN as HR. This is the yellow one is the HR VLAN. So this has been created. Now we will create another VLAN, VLAN 200 as shown here, and we will name this one as the IT. So now let me show the VLANs again using the show VLAN brief command. So it is showing error because this command can be executed in the privilege executive mode. So show VLAN brief, and sure enough, now we have the default VLAN 1, VLAN 100 and VLAN 200, and they are named as HR and IT. But again, we have all the interfaces in this default VLAN. So now we will go to the task 4 and we will assign interfaces to these newly created VLANs. So the task 4 is that we will assign fast Ethernet 01 and 02 to VLAN 100. So this is 01 and 02 of the switch. We will assign these interfaces to VLAN 100, which is this yellow HR VLAN. So again, we will go to the global configuration mode, and to assign an interface to VLAN, what we will do, we will go inside the interface fast Ethernet, and the first one is the 0/1, And there are two commands to assign an interface to VLAN. First, we will change the mode of the interface to access, switch port mode access. And the second command is switch port access VLAN 100. So that's it. Now the 01 interface is in the VLAN 100. We will do the same for the, so using the up arrow key, you can recall the previous commands. So I'm doing the same. I will now go to interface 02 and enter switch port mode access and switch port mode access, switch port access VLAN 100. So remember, we named the VLAN. Here you can give description to the interfaces. Let's suppose this 02 is connected to which device? PC1. So you can say that this is connected to PC1, and you can also say that this is John PC. So you can give description to this interface as well. So now we will assign interfaces 03 and 04 to VLAN 100. So we will go to interface 03, again switch port mode access, switch port access and VLAN 200. And I will do the same for the interface 04, switch port mode access, switch port access and VLAN 200. Now let me show the VLAN brief command again. And sure enough, now we can see that we have two interfaces, fast Ethernet 01 and 02 inside VLAN 100, and two interfaces, fast Ethernet 03 and 04 inside VLAN 200, named as IT. So now again we will do the ping test. So as I said in the task 1 that let me save the configuration first. We are done. Now since we created the VLANs, now let me ping again. This time I will go to desktop and let me first ping the PC2 IP from PC1 and dot 1.1.2. Sure enough, it is pinging because they are in the same VLAN. Now I will ping laptop 1 IP, which is 3, and well enough, sure enough, it is not pinging because these devices are now in a different VLAN. Although they are in the same subnet, still the PC1 is not able to ping it because now we have segregated them. So that is the magic of the VLAN. If I want try to ping the laptop 2, I will again won't be able to ping it because now these devices are in different VLANs. So what if now I want to ping these devices among each other? Then I will have to do inter-VLAN routing. And that is the topic of our next lab. So stay tuned for the next app. Subscribe, like, and share the video. Thank you and see you in the next lab. So welcome to the lab for VLAN trunking. So before going into the task, let me first introduce the lab setup. So we have here with us two switches, switch 1 and switch 2. And we have two PCs connected to each switch. PC1 and PC3 are connected to switch 1 and PC2 and PC4 to switch 2. And we have two VLANs basically here. PC1 and PC2 are in VLAN 10, that is HR VLAN. And I have already given IP addresses to these PC 192.168.10.1 and 192.168.10.2. And PC3 and PC4 are in a second VLAN, that is VLAN 20 of sales, and their IP addresses are 192.168.20.3 and 192.168.20.4. So let me now go through the task briefly. Task 1 will be, I will introduce the need for using the VLAN trunking. In the task 2, I will configure the VLANs and assign the ports to the corresponding VLAN on switch 1, and I will do then the same on switch 2 in the task 3. In the task 4, I will then do the connectivity test by pinging PC2 from PC1 and PC4 from PC3. And in task 5, I will configure trunk ports. I will configure this gigabit 01 and gigabit 01 on both the switches and trunk ports. And in the task 6, I will again test the connectivity between these PC1 and PC2 and PC3 and PC4. So what is the need for VLAN trunking? So in our previous lab, we have a single switch and we assigned multiple devices to two VLANs, and it was good enough. They were able to ping each other, the devices in the same VLAN, while the devices in the different VLAN, they were not able to ping each other as per our requirement, as per the security and segmentation requirement. But in practical scenario, we often have multiple switches. For example, this switch one may be in one building or in one office where we have multiple clients, and then we may have another switch in another building or in adjacent office where there are other multiple clients, and these switches may be connected with each other. So in a single switch setup, these ports are in access, and in access mode, each port can be assigned only one VLAN. But in this case, as we see in the picture, I have VLAN 10 over here and VLAN 20 over here. So this VLAN 10 will need to talk to this VLAN 10 client. That is, PC1 will need to talk to PC2 over VLAN 10, and PC3 will need to talk to PC4 over VLAN 20. What does this mean? This means that now this cable will need to carry multiple VLAN. In this case, two VLAN, VLAN 10 and VLAN 20. While in access mode, each port or the cable can carry only one VLAN. So we need to do something extra, and that extra is configuring these ports in trunk mode. So in trunk mode, the port can carry multiple VLANs, while in access mode, it can carry only one VLAN. So that's why we need to configure trunk where we need to transport multiple VLANs. So now let's get to the practical work. In task 2, I will now configure VLANs 10 and 20 on switch 1 and assign these port past Ethernet 01 and 02 to that specific VLAN. So let's get started. So I will go to the privilege executive mode, then global configuration mode. And now I will configure two VLAN 10, and I will name it as HR. Then I will configure the second VLAN, which is VLAN 20. and I will name it sales. So I am done with configuring VLAN. Now I will assign the ports to these VLAN. The fast Ethernet 01 will be assigned to VLAN 20. So you will go into the interface fast Ethernet 01, and as we did in the previous lab, switch port mode access. So since this cable is directly connected to client and need a single VLAN, so we will configure it in access, switch port access and VLAN 20. Now we'll go into the second interface, which is fast Ethernet 02. And again, I will repeat the same commands. First, I will configure this interface into access mode, and then I will assign it to the VLAN 10, which is our HR VLAN. So configuration on this switch is now done. I will save the configuration. So I can save the configuration using two commands, either copy running configuration to startup configuration, or the second command is write memory. You can use anyone you like. So now let's go to the second switch, switch 2. Let me first change the host name of the switch. So this is switch 2. And now I will configure the 2 VLAN over here. VLAN 10 named as HR, and the second VLAN is VLAN 20, and I will name it as sales. And now I will assign interfaces, that is fast Ethernet 01 and fast Ethernet 02. First, the fast Ethernet 01, I will configure it in access mode. And now I will assign it to VLAN 01 to VLAN 10. I will do the same for the fast Ethernet 02, and I will configure it in access mode, and I will assign it VLAN 20. And now I will save the configuration. Good enough. So now so we are done with the task 3. I have configured VLANs on both the switches and assigned the corresponding interfaces to those VLANs. So now the task number 4 is to test the connectivity. I will ping PC2 from PC1. So let's go to the PC1, and I will ping. Let me bring it up. I will ping PC2, and the PC2 IP is 192.168.10.2, and it is not pinging. It is because we haven't configured these ports, the gigabit Ethernet 01 of the two switches, into trunk mode. These ports are simply into access mode, and that's why the VLAN are not traveling. So I will do the same test for PC3 and PC4. I will ping PC4 from PC3 and PC4 IP is 20.4, and it is also not pinging as we are seeing. So we have done with the connectivity test, that is task number 4. So now let's go to task number 5, which is configure trunk port on switch 1 and switch 2. And the trunk ports we need to configure are the gigabit Ethernet 01 and gigabit Ethernet 01 on both the switches. So first let's go to the switch 1. I will go to the global configuration mode and go inside the gigabit Ethernet 01, and now I will configure this interface into trunk mode. So I will configure it into trunk mode, and now it is good enough. I can now go to the other switch and simply configure the other interface into trunk, but I will do something extra. When you configure interface simple into trunk mode, then it can carry all the VLANs. Any VLAN tag will be carried by this one, but more secure and more controlled way is to only allow the VLANs that you need to carry on this interface. In our case, VLAN 10 and VLAN 20. So what I will do now, switch port trunk allowed VLAN 10 and switch port trunk allowed VLAN, and now I will use this command to add the extra VLAN 20. So now if I show you the running configuration, and here we can see that interface gigabit Ethernet 01 is in trunk mode, and two VLANs, VLAN 20 and VLAN 10, are allowed on this particular interface. So this is safe and secure manner. Instead of allowing all the VLANs, you should only allow the VLANs that you need to allow on this specific interface or that are required to travel on that specific cable. So now I will go to the switch 2. I will do the same configuration over here. And here again, I will go to the interface gigabit 0/1, and I will configure it into trunk mode and port trunk allowed VLAN 10 and add 20. So this interface is again also configured into trunk mode, and two VLANs 10 and 20 has been allowed on this interface. So let me save the configuration. Let me save the configuration on this as well. One thing that I forgot to do is change the name of this switch to switch 1 and save the configuration. So we are good to go. So we are done with the task 5. Now ideally these two PCs will be able to communicate with each other because they are in the same VLAN, and similarly these two PCs in VLAN 20 or sales will be able to communicate with each other. So let's test the connectivity again. I will again go to PC1 and ping PC2 from it. So I will again ping PC2 IP is 192.168.10.2, and sure enough, we are now able to ping PC2 because now VLAN has been made to travel through these interfaces and through this cable. I will now perform the second test by pinging the PC4 from PC3, and PC4 IP is 20.4, and sure enough, it is also pingable. So our configuration and our tests are successful. So I hope this lab has been informative. If there is any question or any conception issue, or if you need to know something extra, you can ask me in the comments. In the next lab, we will be performing the router on a stick. That now let's suppose we want to make the communication between these two VLANs. Let's suppose I want to be able to ping PC2 from PC3. So how should we do that? And we will do that in the next lab. So please subscribe, like, and share the video, and stay tuned for the next lab video. Thank you and bye. So welcome to the lab 5 Inter-VLAN Routing. And in this lab, we would be performing these following tasks. Task 1 would be the introduction to Inter-VLAN Routing. In the task 2, we will be configuring these two VLAN 30 and VLAN 40 on this switch, and then assign the ports to these two VLANs. In the task 3, we will be testing the inter-VLAN communication. And how would we test it? We will perform a ping request from PC1 to laptop 1. And by default, we won't be able to ping laptop 1 because these two devices are in different VLANs. And VLAN are meant for the purpose to segregate traffic. So two different VLAN do not communicate with each other. So in order to make them communicate in the task 4, we will configure SVIs, which is switch virtual interface for both of these VLANs. And after configuring the SVIs in the task 5, we will again test the inter-VLAN communication or inter-VLAN routing by pinging the laptop 1 again from PC 1. So let's get started. So task 1 is what is the inter-VLAN routing and why we need it. So inter-VLAN routing is basically the process of allowing communication between different VLANs. So since VLANs are isolated by default, a router or a layer 3 switch is needed in order to make communication between them. So this switch, this 3560, this is not a normal switch. This is a multi-layer or a layer 3 switch, which means that it can perform layer 3 routing. So there are multiple methods of performing the inter-VLAN routing. In this specific today's lab, we will be performing the inter-VLAN routing using this multi-layer switch. We can also use a router, which is also known as the router on a stick method, that we would be performing in the next lab. But in today's lab, we are simply using a layer 3 switch. So let's get to the task 2 and get to the practical work of configuring VLANs and assigning ports to the VLANs. So let's get to the switch CLI. And first of all, let me change the host name of the switch as per the diagram, which is switch 1. And now I will configure two VLANs, VLAN 30. So the first VLAN is VLAN 30, and I will name it as HR, and I will assign the fast Ethernet 01 to this VLAN. So I will go to the interface, fast Ethernet 01. I will configure the interface into access mode, and then I will assign it to VLAN 30 that we just created. Now at the other side, I will create the second VLAN, which is VLAN 40. I will name it as HR as per the diagram, and sorry, there is a conflict. So this one is HR, the green one, and the blue one is let name is at IT. So I will name this as IT, and I will assign the fast Ethernet 02 to this VLAN. I will go into the interface, fast Ethernet 02, switch port mode access, and switch port access VLAN 40. So we are done with the configuring the VLANs and assigning. Let me save the configuration. The configuration is saved. We'll close the CLI. So we are done with the task 2, which is configuring the VLANs and assigning these ports to the specific VLANs. So now let's go to the task 3, which is testing the inter-VLAN communication. So we have now two VLANs, VLAN 30 and VLAN 40. We will test the communication by pinging the laptop 1 from PC1. I will go to the command prompt, and the laptop 1 IP address is, I will ping 10.10.40.1, and it is not pinging because both these devices are in different VLANs, and by default different VLANs do not communicate with each other. So we will go to our task number 4, which is the main task of our today's lab, and that is configuring the SVI switch virtual interface, or you can also say that configuring the layer 3 interfaces for both these VLANs. So we'll go again to the switch. We'll go into the global configuration mode, and this is how we will configure the SVI. First of all, we will configure the SVI for VLAN 30. So I will use the command interface VLAN 30. Okay, and I will assign IP address 10.10.30.254. This IP address will actually work as a gateway for all the clients that are in this VLAN, and subnet mask will be 255.255.255.0, and I will use the command no shutdown so that this interface, layer 3 interface, is in up mode, and I will exit, and now I will configure the same SVI for VLAN 40. I will assign the IP address to this, which is 10.10.40.254, and the subnet mask is 255.255.255.0, and I will again use the no shutdown command. So that I will also use, so that's it. We are almost done with the configuration. Configuring the SVI. So configuring the SVI is very simple. You just enter the command interface VLAN and then the specific VLAN ID that you want to configure the SVI for, and then you give the IP address, which is basically the gateway for all the clients, and that's it. Now again, we will test the Inter-VLAN routing by pinging the devices again of these two different VLAN. So I will go to the command prompt again and I will try to ping the laptop again, and it is, I think, not pinging. Okay, so we forgot one thing, which is the default gateway. I have given the IP address to both the devices, but I haven't given the default gateway that I just configured, which is the SVI. So for VLAN 30, it is 10.10.30.254. So this is default gateway. It is basically a default route for this PC, and I will configure the default gateway for laptop of VLAN 40 as well, which is 10.10.254, and that's it. I will try to ping it again. I'll go to the command prompt and let me ping it again. Once again, it is not pinging. So let me first, we will do this step by step. Let me first ping the default gateway of the PC1, which is 254. Sure enough, it is pinging. Now let me ping the SVI of VLAN 40, which is also pinging. So, but I am not able to ping the laptop. Network is very fun when you are in troubleshooting the network issues and error. So let's see what's the issue. 10.40.254, sure enough, and 10.10.40.1. Yes, everything seems to working condition. Let me check the firewall. Firewall is off. What else? Let me go back to the switch again and let me show the operation. We may have missed something. Good enough. 40.254, 30.254. Where is the issue? Let me check again. Nope. Okay, sure enough, it is able to ping now. So the issue was that we just forgot to enter this command. So this command is used to enable the routing between VLANs. So it is since it is a switch, it enables the switch to route traffic between VLANs. So that's it. We are done with the successful inter-VLAN routing. So that's it for today video. So please subscribe and stay tuned for the next lab. See you soon. Hi everyone and welcome to our lab 6, that is router on a stick configuration. So in our previous lab we performed inter-VLAN routing using a layer 3 switch. In this particular lab we are doing the same thing, that is inter-VLAN routing, but in this case we are using a router. So when a router is used in this particular fashion, it is known as a router on a stick configuration because we are using this one connection of a router to perform inter-VLAN routing, and this seems like a stick. That's why it is called as router on a stick configuration. So task 1 is the lab setup introduction. So this is our lab setup. We have two PCs. The PC1 is in VLAN 10, having IP address of 192.168.10.1 and gateway of 254. PC2 is in VLAN 20 and its IP address is 192.168.20.1 and having a gateway of 20.254. So this gateway of both these VLANs will be defined on this router to perform this inter-VLAN routing, and we have a layer 2 switch in between them to provide connectivity. And as I already told that this inter-VLAN routing is done using a router, and this inter-VLAN routing configuration setup is known as router on a stick. So let's go to the task 2 and start the practical configuration. So in the first step, we will configure the switch. So let's open the switch CLI. Let me go to the global configuration mode. First of all, we will change the switch name according to our topology diagram. So the first step is configuring the VLAN. So we will configure two VLAN. The first one is VLAN 10 and we will name it as HR. And the second VLAN is VLAN 20 and we will name it as sales. And then the second subtask of the second task is assigning ports to the VLANs. So the fast Ethernet 01 port will be assigned to VLAN 10. So I will enter into fast Ethernet 01 and I will configure it to access mode and I will assign it VLAN 10. In similar fashion, the second PC is connected to the fast Ethernet 02. So I will go into the interface fast Ethernet 02 and I will configure it into access mode and I will assign it VLAN 20. And the third subtask is configuring the trunk port. This one port, the gigabit 01 that is connected with the router. We are configuring it as a trunk because this particular port will be carrying multiple VLANs. In this case, two VLANs, VLAN 10 and 20. So I will go to the interface gigabit 01 and I will configure it as switch port mode trunk. We can also give the port as a description so that we understand when we see the configuration that what this port is connected to. So this port is connected to router. So configuring the port simply in trunk mode is enough. As I told in one of the earlier lab that it is good to assign only the VLANs to this port to allow only the VLANs that are being carried on this port. In our case, VLAN 10 and 20. But in this particular case, we will just leave it as that. So the port has been configured as trunk and we are done with the task 2 as well as configuring the switch. I will copy the running configuration as a startup configuration and that's it. We are done with the switch configuration. And now the task 3 is the configuration of the router and let me open the router CLI. Go to the configuration mode and the first step is changing the name of the router as per the diagram, which is R1. And now we will configure the sub interfaces for both the VLANs. So how will we will do this task? In order to configure sub interfaces, we will go into the interface gigabit 0/1 dot. First of all, I will configure the sub interface for VLAN n. So I will use the command gigabit ethernet 01.10. So now as you can see, I am in the sub interface, this 10, and I will use the encapsulation dot 1q and I will give the ID of the VLAN. Next, I will assign the IP address that is 192.168.10. Remember this gateway, I will assign this gateway IP address over here, or this will act as a gateway for all my clients inside VLAN 10. Assign the subnet mask 255.255.255.0. So I will exit it. I am done with this sub interface. Now I will go again into the physical interface and the sub interface this time 20. And I will again use the encapsulation.1q and this time I will assign the VLAN ID of 20 and I will assign the IP address of 192.168.20.254 and the subnet mask of 255.255.255.0. So I am done with this configuring these sub interfaces. One important thing that remains, as we can see that this interface is down, it is because by default the router interfaces are in shutdown mode. So I will again go into the physical interface And this is also our task, subtask 2 or task 3 to enable the physical interface. I will use the no shutdown command, and this will bring the interface up as well as the sub interfaces or logical interfaces. So now I'm done with this configuration. I will save it. So the configuration is now saved, and in a moment the router interface is up. The switch interface will also come up in a moment, and this is up. And now we can perform the last task, which is testing the connectivity or testing the, we can say, the inter-VLAN routing between the client. So do that. I will go to PC1 and ping the PC2 IP address. So the PC2 IP address is 192.168. So remember, the good approach is to go step by step. First of all, let me ping my own gateway, PC1 own gateway, and it is pinging. Let me now ping the gateway of the VLAN 20, and it is also pinging. And now let me ping the PC2 IP, which is 20.1. Let's wait, and it is also pinging. The first packet is timed out because it takes a time to do the ARP request, and when the reply comes from the PC and the MAC address is learned, then we receive reply as such. So the first time out is because it is learning the MAC address of PC2 for the first time. So now I will ping PC1 from PC2, and PC1 IP address is 192.168.10.1, and sure enough it is also pinging. So our lab configuration is successful, and we have performed the inter-VLAN routing using a router, also known as router on a stick. So that's it for this lab. Subscribe and stay tuned for the upcoming labs. See you next video. Hi everyone, and welcome to lab 7, static route configuration. In this lab we will configure the static routing using this topology, and we will performing these 6 tasks. But first of all, let me clarify and explain that why use static routing. So routing can be done either through static manual configuration or using dynamic routing protocol. So static routing is used where you have a simple and small network such as this one, and it offers us many advantages such as simplicity. We can configure it with minimal resources and predictability, and it does not have any overhead as compared to the dynamic routing where we have regular updates of routes. It is static and manual, and once configured it remains as such unless changed by the administrator. It is also more secure because you know your destination, your next hub, and you can configure specific routes as compared to the dynamic route where big routes and big networks are learned by the routers themselves. And it is also cost effective for the smaller network. So some of the limitation of the static routing are that it is not scalable. It can be used for smaller and manageable network, but once network grows, it is not so scalable and becomes cumbersome, and that's where we use dynamic routing. And secondly, that you have to do everything manually. You have to add, delete, and configure the route manually as compared to the dynamic routing protocols. And third limitation is that it is not adaptable to the link failure as compared to the dynamic routing. So now let's go to the actual task. The first task is to assign the IP addresses to our clients, which is PC1 and laptop 1. So we'll assign these IP addresses. Both these are in different networks, and these, beside the IP addresses, we'll also assign them the gateway, which will be basically the interface of the route facing the client. So let's start the configuration. First of all, let me assign the gateway, which is 192.168.1.1, sorry, 1.254. So this is the gateway, and IP address is 192.168.1.1, and subnet mask is 255.255.255.0. And let me assign the gateway and IP address to the laptop as well. So the gateway is n.1.1.254, and the IP address is n.1.1.1, and subnet mask is 255.255 and 255.0. So that's it. We have assigned the IP addresses to the clients. So we can also configure the switch, but it is not needed in this simple topology. So we will leave the switch in its default configuration, and it will do the work. If we had multiple VLANs and multiple clients, then we had to configure the switch to assign interfaces to different VLANs and create different VLANs, and the configuration on the router will also be would have been different. In that case, we had to configure the router on a stick as we did in our previous lab, but in this case we will simply assign the IP addresses to the router interfaces, and which is task 2. So the task 2 is assigning the IP addresses to R1 interfaces. So we will go to the CLI of R1, enter, and I will go into the global configuration mode, and first of all I will change the host name to R1, and now I will assign the IP addresses to the R1 interfaces. First of all, I will assign the IP address to gigabit interface 00. So interface gigabit 0/0, and IP address, which is 192.168. This is the IP address that I will be assigning. .1.254, and the subnet mask is of course 255.255.255.0. I can also give description to this interface, that is to or towards switch 1. This is connected to switch 1. So by default, all the router interfaces are in shutdown mode. So I will enable it, and the interface has come up. Now I will assign the IP address to its second interface, which is gigabit 0/1. So I will go to the interface 0/1, and the IP address that I will be assigning is 172.16.1.1. So IP address 172.16.1.1 and the subnet mask is 255.255.255.252, and I will also enable this interface, and I will also give it the description to R2. This interface is connected to R2. I will save the configuration. So we are done with assigning the IP addresses to R1 interfaces. Now I will do the same configuration on R2. Go to the CLI. You will go into the user privilege mode and then the global configuration mode. First of all, let me change the host name to R2. Now I will configure its interfaces. First of all, I will configure the interface that is connected with switch 2. That is interface gigabit 0/0, and I will assign it the IP address 10.1.1.254 written over here, and the subnet mask is 255.255.255.0, and again I will enable it. It is in shutdown mode, so as you can see the interfaces has come up. I can also give it description to switch 2, and now I will assign the IP address to its interface gigabit 01. So I will go into the interface gigabit 0/1. I will assign it the IP address 172.16.1.2 and subnet mask are 255.255.255.252. I will also enable it, and I can also give it description to R1. I will save the configuration. We can use both the commands write memory or copy running configuration, startup configuration. Both are equal and good. So now we can see that all the interfaces are up, and we have done with the task 2 and task 3. Now let me ping the laptop from PC1 or PC1 from laptop 2. Let me go to the desktop command prompt and let me ping the laptop IP, which is 10.1.1, and it is not pingable. It is also giving us a clue that router is saying that destination host is unreachable. This is, remember, the router IP. It is because we need to configure static route on this router R1 for this specific destination. And if I ping my router IP 1.254, so it is pingable. So we can reach over here, but to reach over here, we need to configure a static route on router 1 to tell it that in order to go or to reach this destination, your next hub is this router R2. So our task 5 and the important task that this lab is about is the configuration of the static routes on both R1 and R2. So first of all, I will go to the router R1 and I will go to the global configuration mode, and now I need to configure the static route for this network 10.1.1.0/24. and this will be my destination, and my next hop will be this router R2, this IP, which is 172.16.1.2. So this is how I will configure the route. The command is IP route, and next I will give the destination, which is 10.1.1.0, and the subnet mask of the destination, which is 255.255.255.0, and then the next hop. So on router 1, my next hop is router 2 gigabit 01 interface, which is 172.16.1.2. 172.16.1.2, and that's it. So I have uh, done with this static route. Now I will also configure the static route on R2 so that laptop 1 can reach PC 1. So on R2, we'll go to the global configuration mode, and my route will be, I am configuring the route for this destination, that is 192.168.1.0, having the subnet mask of 255.255.255.0, and my R2 next hop will be R1 gigabit 01 interface having IP address of 172.16.1.1. So I will give the next hop IP 172.16.1.1. Let me save the configuration. And now I will test the connectivity again. I will again ping the laptop from PC1. First packet may be timed out because the router needs to learn the MAC addresses of these destinations. So we can see that the laptop 1 is now reachable, and if I ping the PC1 from laptop 1, it will also be reachable. 192.168.1.1. So sure enough, PC1 is also reachable from laptop 1. So that's it for this lab. In the next lab, we will see the dynamic routing, and we will specifically configure and study the dynamic routing protocol OSPF, Open Shortest Path, first. So stay tuned, subscribed, and see you in the next lab. Hi everyone, and welcome to the lab 8 OSPF configuration. So OSPF is a dynamic routing protocol. In the previous lab, we did the routing using the static routing, and in this particular lab, we are using the dynamic routing. And for the dynamic routing protocol, we have chosen the OSPF. So this is the lab topology. We have three routers, R1, R2, and R3. And we have two networks, 192.168.1.0 and 192.168.2.0. The purpose of this lab is to make the PC1 and PC2 communicate with each other using the OSPF dynamic routing protocol. And this OSPF will be configured on these three routers. So as we can see, the routers are connected to each other. R1 and R2 are connected to each other using the 10.1.1.0/30, and R2 and R3 are connected to each other using the network 10.1.2.0/30. And .1 and .2 are their specific IP addresses on each router sites. So let's get started. So the first task is to assign the IP addresses and gateways to the PC. So I have already done this. On PC1, my gateway is 192.168.1.254, which I will configure on router 1 gigabit 01 interface. And this is the IP address 1.1 that I have already given to the PC. And in similar fashion, I have given the gateway 2.254 to PC2, and its IP address is 2.1. Now we will start with the task 2 and the actual configuration on all these three routers. So the first task of the configuration is to assign the IP addresses to all the routers. So let's start with the router R1. So let's go to the global configuration. First of all, I will change the host name of the router to R1. And the next is I will assign the IP addresses to its interfaces. First, let me assign the IP address to interface gigabit 01, which is connected to the PC. And I will assign IP address 192.168.1.254 with the subnet mask 255.255.255.0, and I will also enable the interface because it is in shutdown mode by default. I can also give it description to PC1. Now I will go to the interface gigabit 0/0, which is connected to R2. I will assign it IP address, this one, 10.1.1.1 with the subnet mask 255.255.255.252 because it is /30. And I will also enable this interface and give it the description to R2. So that's it. I'm done with the R1. I will save the configuration, and now let's do the same configuration on R2. Let me first change the host name to R2, and now I'll assign the IP addresses to its interfaces. First of all, let's go into the interface gigabit 0/0 and assign it the IP address of 10.1.1.2, having the subnet mask of 255.255.255.252, and I will also enable the interface, and I can also give it the description to R1. And similarly, I will now go to its second interface, which is gigabit 0/1, and I will assign it IP address 10.1.2.1 and 255.255.255.252 subnet mask, and I will also enable it and give it the description. It is connected to R3. So I will save the configuration. So that's it for R2. I will do the same configuration on R3. First of all, let's change the host name of R3, And now I will assign the IP addresses. First of all, let's go into the interface gigabit 0/1 and IP address 10.1.2.2 and 255.255.255.252 will also enable it and give it the description 2 or 2. Now we'll go to its second interface, which is gigabit 0/0 connected to PC, and I will assign IP address 192.168.2.254 with the subnet mask 255.255.255.0, and I will also enable it and give it the description to PC2. I will save the configuration, and that's it. So we are done with the task 2. So now if I ping PC2 from PC1, so PC2 IP is 192.168.2.1. Ensure it is not pinging because we need to do the OSPF configuration in order to route this network over here. So the task 4 and the important task is the configuration of the OSPF. So first of all, I will configure the OSPF on router 1. I'm here on router 1. I will go into the global configuration mode and I will define an OSPF process ID. I can define, so this ID is local. It is not advertised with other router, so you can choose any ID. If you use the question mark, so it can range from 1 to 65,535. Let me choose one for this one. And now I will use the networks, configure the networks that I want to advertise through this OSPF. So on router 1, my network that I want to advertise is this one, 192.168.1.0, which is the PC network. And here I am using the wildcard address and I am using OSPF area 0. Similarly, I will also configure the second network with which router 1 is connected to router 2, which is 10.1.1.0 with the wildcard. Sorry, this is 10.1.1.0, 0.0.0.3, and again area 0. So that's it. That is the OSPF configuration on R1. Now I will do the same configuration OSPF excuse me on R2. So I'll go in the global configuration mode and R2. I will configure the two network that R2 needs to advertise. First of all, I will define the OSPF process ID. I can choose any ID. It should not, or it can be same, but it is not necessary that the process ID needs to be same on all the router. You can choose different ID because, as I said, these are local to the router and are not advertised across the routers. I will choose the process ID 2 here. I will choose the networks that I need to advertise 10.1.1.0 .3 and the area 0. and the second network is 10.1.2. So I will write 2 over here, and as we can see, the OSPF is doing its job, and the two routers are forming adjacency and neighborhood. Now we'll exit this and go to the router 3 for the OSPF configuration. And on router 3, I can again I will define the OSPF process ID. I am choosing 3 over here, and the network that I will advertise are 192.168.2.0 and the wildcard address 0.0.0.255 and the area 0, and the second network is 10.1.2.0 and the wildcard address dot 3 and area 0. So that's it. As we can see, OSPF neighborhood and adjacency are being formed. So that's it. That's all the routing OSPF configuration that we needed to do on the router. So now let's again test the connectivity. I will again ping the PC2 from PC1, and sure enough, PC2 is now pingable. I can also ping PC1 from PC2. PC1 IP is 192.168.1.1, and it is also pingable. So now let some OSPF commands. It will not be that straightforward. You may encounter some errors, or you will have to do some troubleshooting. So in order to do troubleshooting, you can use some of these commands such as show IP OSPF neighbor. So this command will show you the neighbor that you are connected to. So in this case, it is also showing that the state, it is in full state and PDR configuration, and my R1 neighbor is of course 10.1.1.2 with the interface and dot. Okay, so this is my neighbor's information. Its interface is, it is basically showing this interface 10.1.2.1, and its address with me is 10.1.1.2. Another command that you can use is show IP route, and this will then show that all the routes that have been learned through the OSPF. This O stands here for the OSPF. Another important command that you can use is show IP OSPF database, and this will also give you the necessary and important information. So that's all for this lab. I hope this has been informative. So I purposely chose the simple and easy topology so that you actually learn the concept and the purpose of the lab, such as the OSPF configuration. I can also choose complex topologies with many routers and connectivity. But then the real purpose of the lab is buried somewhere, and we are just doing the troubleshooting and the connectivity and all sort of things. So that's the purpose of choosing these simple topologies. So I hope you have learned something from this lab, and please subscribe and share the video to support the channel, and see you in the next video. Hi everyone, and welcome to the Lab 9 ACL configuration. So in today's lab, we will configure the access control list using this topology, and we will be performing these 5 tasks. So first of all, let's go through the definition and understand that what are the ACLs. So ACL, known as access control list, is a set of rules used to control network traffic by permitting or denying network packets. So in this way, it enhances security by filtering traffic at the network or at the firewall. And basically, there are two types of ACL: standard ACL and the extended ACL. So the standard ACL filter traffic based only on the source address. It is simple and basics. While the extended ACL, it has multiple parameters and it uses source, destination address, protocol, and port number to granularly filter the traffic. So that's brief definition of the ACL. Now let's get started with the task. So the first task is to assign IP addresses to PCs and the server. So this is basically server. We have no laptop. And these are the IP scheme that we will be using. These two PCs are in the network 10.1.1.0/24. So PC1 has 10.1.1.1 and PC2 has 10.1.1.2. And their gateway is here defined at the router interface gigabit 01, which is 10.1.1.254. The server and PC3 are in another network, which is 192.168.1.0/24. The server IP is 1.1 and its gateway is 1.254, which is router 1 gigabit interface 0/0, and PC3 IP is 1.2 and its gateway is also 1.254. So I have already assigned the IP addresses and gateway to the PCs as well as the router. So we are done with the task 1. Task 2 is to assign IP addresses to R1 interfaces. So let's get started with the task 2. Let's open the router CLI and let's go into the global configuration mode. First of all, we'll change the router host name to R1. And now I will assign IP addresses to its interfaces. First of all, I will assign the IP address 10.1.1.254 to interface gigabit 01. So I will go into the interface gigabit 0/1 and I will assign it IP address 10.1.1.254 with the subnet mask 255.255.255.0, and since it is in shutdown mode, I will use the command no shutdown to enable it, and I will also give it the description to PC1, PC2. I can also use to switch one. And that's it with the interface gigabit 01. Now I will do the same configuration on gigabit 00 and I will assign it the IP address this 192.168.1.254 and the subnet mask of 255.255.255.0. I will also enable it and give it the description to server and PC3. So that's it for this configuration. Let me save the configuration. So as we can see that interfaces are coming up because I have enabled the interfaces. So we are done with the task 2, assigning the interfaces to router R1. So now if you can check the connectivity, these network will be able to ping each other. These both the PCs are able to access the server as well as PC3, and PC3 is also able to access the PC1 and PC2. So our purpose of the ACL is to allow PC1 to access HTTP server, which is this one, and deny PC2 to access this server while the rest of the traffic will be allowed. And similarly, we will make another ACL which will be to deny PC3 accessing this PC1 and PC2. So let's first check the connectivity without ACL. If I go to the PC2, I go to the desktop and browser, and if I type over here the server IP, it is acting as an HTTP server. So as we can see, currently the server is accessible from PC2. So the our purpose of this lab is to make an ACL to deny PC2 from accessing this server. So let's start with the ACL1, which is to allow PC1 to access HTTP server and deny PC2 to access the HTTP server. So I will go into the global configuration mode, and now I will make the ACL access list, and I can now type the access list number. This number, since I am making an extended ACL, so this number, this will range from 100 to 119. This is for extended. Since I will be using port number and destination IP for HTTP server, therefore I need an extended ACL. So I will, the range for extended ACL is from 100 to 119. I will use 100, permit, and then the, since it is HTTP, the protocol is TCP. If you write question mark, so these are the different protocol options that are available with me. So I am using TCP, and next I am specifying the source host. So first of all, the source is 10.1.1, which is PC1, and next will be the destination host, which is 192.168.1.1, and at the end it is the EQ equal to, I will give the port number of the destination host, which is HTTP port 80. Port 80 is used for HTTP. I will enter. So this is access list extended having the number 100. I am permitting TCP traffic from PC1 with this source IP to our destination IP, which is server IP, this, and the destination server service, which is HTTP, being served at port 80. The next line for the same access list will be for PC2. So again, I will write the access list 100. This time deny TCP host, which is the source, 10.1.1.2, which is the PC2 IP, and again the destination, which is 192.168.1.1, and again deny access to port 80, which is HTTP. So I have allowed PC1 to access server and denied PC2 to access the server, and allow all other traffic. So beside this, I will allow all other traffic using the same ACL permit IP any source and any destination. So all other traffic will be allowed. So I have made the ACL. Next crucial step is to apply the ACL on an interface of the router. So where I need to apply it, since the server is over here, I will apply it at the gigabit 0/0 so that any traffic that goes toward the server is filtered using this ACL. So how I will do it? I will go into the interface gigabit 0/0 and I will apply it using the command IP access group 100, and I am giving the option in or out. I will use out because traffic will be going out this interface, and that's it. So this ACL is applied. Next is I will So I'm done with the task 3. The next task is to create an ACL for PC3 so that PC3 cannot access PC1 and PC2. So I will make another ACL, this time access list. Let's this time use the number 101 and deny IP host. Host IP is 192.168.1.2 and the destination address. So what is the destination? I will give here the complete network, the complete 10.1.1.0 network. I will use the wildcard address over here, which is 0.0.0.255, and I will enter it, and I will allow all other traffic. Always remember that when you create an ACL, you specifically deny something and you should then allow other traffic, otherwise everything will be blocked. So I have made both the ACL. I will save the configuration, and now the next crucial step is to apply the second ACL for PC3 on an interface. So since PC3 is over here and it will be accessing PC1 and PC2 over here, so the traffic will be coming over here. Therefore, I can apply it on interface gigabit 0/0 as input ACL. So I will again go into the interface gigabit 0/0 and IP access group 101 and in, and exit, and again write memory to save the configuration. So we are done with the configuration, and now we can see the access list that we have created. So these are the two access lists, extended IP access list 100, and the next one is extended IP access list 101. And this order is also important. So the 100 is permitting PC1 to access the, here we can see the port 80 has been replaced with the www, which is HTTP protocol, and denying the access to PC2. And the next is access list 101, which is denying PC3 to access the 10.1110 network. So if you want to check that where these are applied, or if you want to make sure that the access list are applied at the correct interfaces, you can go to the interfaces, and here you will see that the ACL are applied. Let me check where it is. Here you can see that ACL are applied. So that's it. Now we will do the connectivity test. First of all, I will access HTTP server from PC1. So I can go to the desktop, and since it is an HTTP server, I can open the browser and type in the server IP 192.168.1.1, and sure enough I can access the web page on this HTTP server. Now if our configuration is correct, it should not be accessible from PC2. I will again go to the browser inside PC2, and I will again type the server IP address, and here we can see that the page is not loading. It means that it is not, as we can see that it has timed out, so it is not accessible from PC2. We can also test it through this command, telnet command. I can test this. You can test it through ping as well, and the telnet command, telnet 192.168.1.1. Okay, sorry, I didn't specify the port number, which is port 80. I am telnetting the port 80, and sure enough, is it showing me that it is open from PC1. Let me do the same with PC2. Telnet 192.168.1.1 and port 80, and it should not be accessible from PC2. As we can see that it is trying, but it is not accessible and the connection has timed out. So our next, now let's check the second ACL, which was to deny access to PC3, to PC1 and PC2. I will go into the PC3, and I will ping the IP addresses of PC1 and PC2, and here we can see that both of these are not accessible. So it means our configuration is successfully applied, our ACLs are working. I hope this lab has been informative for you people. If there is any confusion or anything else that you want to ask regarding this lab or anything else, you can comment on the video, and I will happy to reply and clear your confusion regarding the configuration or any technical issue. So that's it for today. Please subscribe and share the video by supporting the channel, and we'll see you in the next lab. Welcome to the lab 10, port security. So port security is basically a layer 2 security feature that restricts the number of MAC addresses allowed on a port, and it also helps prevent unauthorized devices to access the network and the switches. So for example, if you allow only this PC to access this switch, and when an unauthorized device or devices try to access the network, you can configure the switch to shut down the port, and in this way prevent the unauthorized devices from accessing the network. So that's what we will be doing in this particular lab. We will be allowing the PC1 and PC2 to access both these switches, and by configuring the port security features, and then we will use a test case where we will try to connect another PC to the switch, and we will see that it will not be allowed to connect to the network, and the port will be shut down automatically by the switch. So let's get started with the task. So the first task is to enable port security on switch 1. So let's get started. So let me open the CLI of the switch. Go to global configuration. First of all, let me change the name of the switch to switch 1 as per the topology. So the PC is connected to fast Ethernet 01 of the switch 1. So you'll go into the interface fast Ethernet 01, and I will, since it is connected to a PC, I will configure it in access mode, and then I will enable the port security on this particular port, and the security feature that I will enable include the maximum. So this command shows that maximum number of MAC addresses that are allowed on this particular port. So since only one PC is connected to this port, we will use the number 1 such that only one MAC address that is of PC1 is learned and connected on this port. And the next command is, so how do we configure the MAC address of the PC to be enabled on this particular port? So there are two options. We can manually enter the port number of this PC. This is one method. The second method is that we can use the sticky command, and when the MAC address of this PC is learned by the switch, it will be automatically saved. So for this particular case, we will use the sticky because it is easy method instead of manually entering the MAC address. So we will exit it and save the configuration. So now we have enabled the port security feature where we have told the switch 1 to allow only one MAC address on this port, and the MAC address will be the first MAC address that will be learned by the switch. So if we show the MAC address table, here we can see that right now the switch has only one MAC address learned, that is on the port fast Ethernet 02, which is the switch 2. The PC1 MAC address is not learned, so what we can do, we can ping the PC2 from PC1 and it will automatically learn the MAC address. N.1.1.2. So now the switch will have learned the MAC address. Let me show the MAC address table again. And sure enough, Now the MAC address of the PC at port fast 0 Ethernet 1 is learned by the switch. So the second MAC address, this one, is of the PC2 since it was also learned during the ping process. So okay, another thing that I forget to configure is there is another command regarding the port security, which is, let me configure it. Let me first go into the interface, fast Ethernet 01 switch port security violation. So if there is a violation of this port security feature, if another MAC address comes on this port, what should the switch do? We have three options. In the protect, the MAC address or the packet will be dropped silently. In the restrict, the packet will be dropped, but the violation will be logged. And in the shutdown, the port will be shut down. The packet will be dropped and the port will be shut down. So this is the least secure. Restrict is more secure than protect because it logs the violation, and shutdown is the more secure option because it shut down the port. So let me configure the shutdown option. So if there is a violation, which we will test in a while, it will shut down the port. So now let me do the same configuration on switch 2 as well. But let me change the host name to switch 2. And now I will again go to the interface on which PC2 is connected, which is fast Ethernet 01. I will configure it into access mode, and now I will enable the port security features, and again I will allow maximum one MAC address, and the MAC address is again will be learned dynamically. And again, if there is a violation of this security feature, the port will be shut down. So we are done with the configuration. Now let me show port security interface fast Ethernet 01. You can verify the configuration using this command on the port. So here we can see that port security feature is enabled and the violation mode is shut down, and some other information. Here we can see that maximum number of MAC addresses allowed are only 1. You can also verify this on switch 1. So now let's do the test. We verify the configurations. We did the configuration, then we verified the configuration. Now we will do some testing. As we saw that laptop is pingable from the PC. And now what we will do, we will connect an unauthorized device to this switch 1 port fast Ethernet 01. So let me remove this connection and let me bring another PC. Let's suppose this is PC 0. and let me try to connect it to its fast Ethernet 0, 1. So as per our configuration, the let me also give it the IP address dot 1.1 dot, let's suppose 3, and the MAC address of 255.255.0. And as we can see that the port status has turned red. Let me open the switch, and here we can see from the logs that the port change has changed to down. And if you want to see, we can use the command show. Again, port security interface fast Ethernet 0/1. And here we can see that port status is secure, shut down, and because violation mode was shut down. So if I use another command show interfaces status, here we can see that it is in disabled mode due to our configuration. So let me bring it back. So I will connect the C1 again to the fast Ethernet 0/1. But since port is in shutdown mode, what I can do, I can go into the interface fast Ethernet 0/1, and since it is already in shutdown mode, I can shut down it and then no shutdown to make it enable, and the port will now come up. As we can see, it will turn green. I can verify it through the command. So port security interface fast Ethernet 0/1, and here we can see that port is secure and in up mode because it has again learned the authorized MAC address. We can test the same with the switch 2 and it will give us the same results. So that's it for this lab. I hope this has been informative. So please subscribe, and if you are preparing for the CCNA certification, I have a practice question video containing about 350 practice questions that will help you a lot in your preparation. So see you in the next lab. Welcome to the lab 11, EtherChannel configuration. So first of all, what is EtherChannel? So EtherChannel basically refers to a technology that combines multiple physical links into a single logical links, and it has mainly two advantages. First of all, it increases the bandwidth of the link. So if this one link is 100 Mbps, so the combined bandwidth will be 200 Mbps. And secondly, it also provides redundancy. So if one link breaks, one physical link fails, if one interface fails, we still have the connection intact through the second link. So these are the main two advantages of EtherChannel, and it can be configured through two main protocol. One is the LACP, that is Link Aggregation Control Protocol, or the PAGP, that is Port Aggregation Protocol. So we can bundle up to 8 physical interfaces into a single Ether channel or single logical link. So this another advantage of this Ether channel is that it prevents loops as well. As we can see here, these red dots here shows because these ports are automatically blocked by the STP because we are forming a loop over here since we haven't configured the Ether channel. Once we configure the Ether channel, the whole multiple links are considered as a single logical link and both link will be active. So it also prevents loops. So in this particular topology, we will be configuring two Ether channel. One is between switch 0 and switch 1. This will be a layer 2 Ether channel. And the second is between switch 1 and switch 2. So the switch 1 and switch 2 are basically multi-layer layer 3 switches. So this Ether link we will configure as a layer 3. So let's get started with the task. So the task 1 is to assign IP addresses to the PC and the gateway. So I have already done this configuration. I have assigned the gateway as well as the IP address to the PC. So this is IP address and this is the gateway that we will configure here on switch 1 as an SVI. The next task is to configure switch 0, configure VLAN 10 and assign port to it and then configure the Ether channel. So let's get started. So enable global configuration mode. First of all, let me change the host name to switch 0 as per the topology. And the second thing that I will be doing is to create the VLAN 10, and let's suppose I will name it as PC0 VLAN. And next is I will assign the interface, this one, fast Ethernet 01 to this VLAN to which this PC0 is connected. Let me configure the port into access mode and assign the VLAN 10, and that's it. So we have assigned the port to the this VLAN 10 that is connected to the PC. Next is we will be configuring the Ether channel, this one. So, and these two interfaces are fast Ethernet 02 and 03. So let me get into both interfaces and here I will configure the Ether channel group 1 and mode active. So what are the options? Option active enable the link aggregation control protocol automatically. So active and passive are basically used for LACP. Passive is enable LACP only if LACP device is detected. So if you configure passive over here, on the other side you must configure active so that they can negotiate, or you can configure active on both side as well. So I will configure active over here. So the channel group shows that I am using the LACP, which is a standard open standard protocol. So I have configured the Ether channel for fast Ethernet 0 2 and 0 3. And now I will go into this EtherChannel interface, port channel 1, and I will configure this. So now all the configuration that I will be doing on this, I will be doing it on this EtherChannel interface instead of the physical interfaces. So mode trunk, because I am configured this EtherChannel as layer 2, so switch port trunk and allowed VLAN 10. I'm only allowing the VLAN 10. So that's it for this configuration for this switch. So I will save the configuration. So now I will go to the switch, next switch, which is switch 1, and I will configure the next task is to configure the VLAN 10 and SVI on switch 1, as well as to configure ether channel with switch 0 as well as with switch 2. So let me go into CLI of switch 1, global configuration mode. First of all, let me change host name to switch 1 as per the topology. And first of all, let me create the VLAN. I can name it to again PC0 VLAN. And now I will configure this layer 3 interface or SVI for this VLAN 10. Interface VLAN 10, and I will assign it the IP address of 10.1.1.254 with the subnet mask 255.255.255.0, and I will use the command no shutdown so that it's enabled. And now I will configure this SVI, the ether channel with the switch 0. So I will go to the interfaces, fast Ethernet 0/2 and 3. It is giving an error. That okay, sorry, I didn't specify the range. Fast Ethernet 02-3, and I will configure the channel group 1 and mode. Here I can choose active or passive. I am choosing the active. Exit. Now I will go into the ether channel, and I will configure it as a trunk encapsulation .1 q, and I will configure it as a mode trunk, and I will allow VLAN 10 on this trunk. So that's it. So as now we can see, it is doing the negotiation. It will come up in a while. Now the next is to configure my another ether channel with the switch 2. So for that I will go into the interface range gigabit 0/1-2, and since I am configured it as a layer 3, I will use this command which will make it layer 3, and Since I am using another Ether channel on the same switch, I will give it the number 2. Again, I will use the mode active, exit. Now I will go into the Ether channel 2. Again, it is layer 3. This command is not required, so I will give it the IP address because I already specified it as layer 3, 10.1.2.1 and subnet mask of 255.255.255.0 and exit. So that's it. I have done the configure both the Ether channel layer 3 as well as layer 2 on switch 1. Now I will go into the switch 2. Let me first save this configuration. On switch 3, enable global configuration mode. First of all, let me the host name to switch 2. And again, I will go into the gigabit interface 01-2. So I just forget to specify the range. And again, I will specify it as a layer 3 and channel group 2 and mode active, exit. Now I will go into the Ether channel face and assign it the IP address, which is 10.1.2.2 and subnet mask of 255.255.255.0. So that's it. We'll save the configuration. And now some test cases are some show commands. So let me first go to switch 0, and this is the command that you can use to show your Ether channel. So it shows us that we have one port channel. The SU stands for S is that it is a layer 2 Ether channel, and U is that it is up or in use. And these interfaces, these are the part of this Ether channel. The protocol used is LACP, and the P here shows that they are both used in the port channel. So let me use the same command over here. So this port channel, layer 3 port channel are just coming up. But anyway, let me show the Ether channel summary command. And here we can see the port channel 1 or the Ether channel 1, it is again up, and S is, it is a layer 2, and the second is, it is also up, but it is not layer 2, it is layer 3. And these are the interfaces that are shown or that are part of these particular port channels. So this is a very handy command. And now let's do some testing. I will do some testing to, you can also use the command over here, show IP interface brief, and here we can see that we have this SVI, it is up, and this port channel is also assigned the required IP, it is also up. So the port channel 2 has assigned an IP address. Port channel 1 is layer 2, so IP address is unassigned. So now let's do some testing. And the test that we will be performing, the first test is to, let's suppose, first of all, ping the gateway from the PC, which is 10.1.1.254, and sure enough it is pinging. Now let me ping the switch 1 IP address, it is also pinging. Let me ping the switch 2 IP address. And it is not pinging because we need to configure a static route from on this switch 2 to switch 1 so that it knows the IP address of this PC. So in any way, let me now check the working of this ether channel. So as we said that the ether channel gave us I'm trying to continuously ping it. I don't know the command for it. Anyway, let do a test scenario. Let me break or delete this one link over here, and now let ping the SVI again. It should work. As we can see, it is working. Although one link is down, the SVI is still pinging. So in this way, it gives us the redundancy. And once you configure the static route over here, you can do it. You can do the same for this ether channel as well. We can test it. This ether channel as such. I can ping the switch 2 IP from switch 1, which is 2.2, and it is pinging. And if I break one link, it should have no effect on the connectivity. It is pinging. We can now check the ether channel, and we can see that one link is now down of the ether channel of both the ether channel, but it is still up. the EtherChannel overall logical interface is still up, it is not down, and the connectivity is still working despite disconnecting or deleting one link. So that's it for today. I hope this has been informative. So please subscribe and we'll see you in the next video. Hi everyone and welcome to the lab 12 net configuration. So in today's lab we will study the network address translation, its different types and its configuration in this topology. First of all, we will study the net definition and its different types. In the task 1, we will configure the PCs and server IP addresses and its gateway, which I have already done. The task 2, we will configure the router R1 basic configuration, including assigning the gateway to the interfaces gigabit 00 and 01. And then in the task 3, 4, 5, we will configure the net. First of all, we will configure the static net, then the dynamic net, and in the last task, we will configure the PAT, which is port address translation. So let's start with the definition of NAT. So NAT or network address translation is a process that modifies the IP addresses in the packet header as they pass through a router. And it basically changes the private IP addresses, which in this case is these PCs IP addresses, to a public IP addresses as the packet goes from the LAN or the private network to the WAN or the internet. So the basic purpose of the net was to preserve or conserve the IP version 4 addresses. It also gives us a little bit of security by hiding the internal IP addresses of our local PCs or servers. And then we have three different types of NAT. The first one is the static NAT, which is the mapping of a single private IP address to a single public IP address. For example, in this case, we can map the PC IP address 10.10.10.1 to a public IP address such as 203.0.113.2. So this is a static one-to-one mapping. In the dynamic NAT, which is the second type of NAT, the NAT basically maps private IP addresses to a pool of public IP addresses dynamically, assigning a different dynamic public IP to each private IP. So we define a pool of public IP addresses, and then each time a private PC or device wants to access the WAN or internet, it is assigned a public IP address. And the last NAT type is the PAT, which is port address translation. It is also known as NAT overload. So it basically allows multiple private IP addresses to share a single IP address by differentiating connection using different port number. So this one is most commonly used because most of the time you have single public IP addresses assigned by your ISP, and of course you have multiple private PCs or multiple devices in your local LAN, and then you use the PAT to access the WAN or the internet. So now let's start with the other tasks. So the task 1, assigning the PCs and the server IP addresses and the gateway, it is already done. And the task 2 is the basic configuration of R1, which I have already done, such as the changing the host name and assigning the IP addresses to the interfaces, such as the gigabit 0/0. This one is assigned an IP address of 10.10.10.254, which acts as a gateway to these for these PCs. And the other interface, which is towards the WAN, connected to the internet, you can say. It has been assigned the IP address of 203.0.113.254, which acts as the gateway for the server. So that is the basic configuration that I have already done. And now we will start with the actual configuration of the netting. So in the task 3, first of all, we will do the static net. So let's get started. We will go into global configuration mode. And we have basically two interfaces of the R1, which is the one is towards the LAN where the packet is entering, and the other one is towards the WAN gigabit 0/1 where packet is going out toward the WAN. So I will go first of all into the interface gigabit 0/0, and I will write the command IPNet. I'm given two options, and I will use the inside because it is the inside interface where the packet will enter the router. So I will use this command as enter, and I will exit. I will now go to the other interface, which is 0/1, and this time I will use the IPNet outside because here the packet is going out toward the WAN or towards the internet, and I will exit. So now I will statically map this PC IP address, which is 10.10.10.1, to a public IP address. Since I have a complete network, I can use any IP address besides this server. Let's suppose I will use the IP address of 203.113.20. So for this, I will use the command IPNet inside source static. So the static command indicate that I am using static net, and the IP address that I am mapping, the local IP address is 1, which is the IP address of this PC0, and the public IP address is 203.0.113.20. So that's it. I'm done with the static net configuration. I can now see it. So as we can see, we have these IPNet inside towards the LAN and IPNet outside towards the WAN interface, and then the actual static mapping of the private IP address with a public IP address. So this is one-to-one mapping. Now I will test the netting process. So first let me see if there is any net translation, and there is this one that we have done, but no dynamic translation yet. So what I will do to test the process, I will ping this server IP from the PC. So I will go to the command prompt. I will ping the server IP, which is 203.0.113.10, and the first packet may be timed out because of the ARP process to complete. And now if we see the translation, the net would have done the trick. And as we can see, now we have these translation. So here we can see that this is, let me read the command again. So this is the inside local address, and this is the inside global, and this is the outside local, and this is the outside global. So basically this was the address, our inside, and this is our outside. And the protocol used for the testing was ICMP, the ping command. So I can clear the IP net translation. I will delete all. So if I see again now, our translation is cleared. So that was the static net configuration and its testing. In the task 4, now we will do the dynamic configuration and testing. I will pause the video over here and erase the configuration on R1 so that we make it ready for the dynamic net. And after I erase or I remove the configuration of the static net, we will then do the dynamic net configuration. Welcome back. So I have removed the static net configuration, as you can see, and now we will do the dynamic net configuration. So now let me go to the interface again. First of all, gigabit 0/0, and I will use the same command, IPNet inside and IPNet outside for the interface towards the internet. And for the dynamic net, as I already said, that we need to configure a public IP address pool. So I will do the same over here, IPNet pool, and so let me get out of the interface, IPNet pool, and I will give it a name. I can give it any name. Let's suppose it is a WAN pool, and I will give it the start IP address 113 dot. Let we start it from 11, and the end IP is 0.113 dot, let's suppose 15, because here we have only 2 PCs, so these 5 IP addresses are enough. I will also define the subnet mask, which is 255.255.255.0, and I will enter it. The next thing that I will need to do is to create an ACL, that is access control list, of the private IP addresses that I need to allow. So I will create this access list, and the permit, which is my private IP address network, and the subnet mask is, I will use the wildcard 00.255, and now I will link this ACL to the net pool. I will link the ACL to the net pool through this command, IPNet inside and source list 1, which I already defined, and pool is the WAN pool, and enter. And now I am done with the dynamic net configuration. Now the next phase is to do the testing. First, let me see the translation. I will go into the exit the global configuration mode, and I will use the command to see the translation. So there is no translation, and after the communication we will see the translation. So first of all, I will ping again from PC1. Let me ping from PC2 as well. So the IP address is 203.0.113.10, and since this is an HTTP server, let me access the web page as well if I can, so that we will see a mix of protocol translation 0.113.10, and here we can see that we have successfully accessed the web page of the server. Now I will go into the router, and I will see the translation again, and sure enough we can see the translation. So as we can see, the since I have defined a pool of the public IP addresses, so for this first packet, or for the first IP address, it has translated to the 10 IP address. No, this is not the case. So this is basically the server IP address, and this is the translated IP address. So this was my local PC IP address, and it is translated to the pool was defined from 11 to 15. So it is translated to this. 10.10.1 is translated to 11, and when I pinged it from the PC2, it is translated to another public IP address, which is 12. Here we can also see that when we use the browser web page, it is also use the port 80 to fetch the web page. So as we can see that when we use the dynamic net, it assigns IP addresses from the pool that we have defined. In this case, we have two local. Our private IP address is 1 and 2, and it has been translated to 11 and 12. So I hope this is understandable. Now I will pause the video, and I will erase the configuration on R1 for the next net configuration, which is PAT. Welcome back. So in this part 3, now we will do the PAT port address translation configuration. And I have erased the previous configuration from the router. Let me show the current running configuration. As we can see, there is no net configuration over here. So there is no net translation as well. So now let's start with the port address translation, and as with the previous net configuration, we will first of all do the same IP net inside. So this set of command is basically same for all three type of net, that common. And now again I will need to configure an access list of my private IP addresses, which is 10.10.10.0 with the wildcard address of 00255. And now I need to use the actual pat configuration command, which is ipnet. Inside is the source list 1 that I just defined with the interface gigabit 0/1 overload. So this is basically the command that will use the IP address of gigabit 0/1 to be translated when there is any private IP address from this network. So that's it. That's the configuration. Now we will do the testing. Once again, let me show the translation. Currently there is no translation. So now I will do some ping and packet communication. Let me ping the IP address of the server, which is 203.0.0.1.3.10. And again, the first packet will be timed out due to the translation and the ARP. Now let me do the same from another IP address, which is PC2. Again, server IP address is 203.0.0.1.1.3.10. Let me also open the web page of the server by entering the server IP address in the address bar, and now we will have some translations. So let me maximize the windows, and sure enough, so now as we can see, this is the IP address basically that we have given to the gigabit 0/1, which is this interface towards WAN. So any traffic that comes through this interface is translated to this interface IP address, which is this, but with a different port number for each IP address. So we can see that for PC2 and for PC1 we have the same IP address but different port numbers. So that's why it is the also known as net overload, because same IP address is overloaded by different local IP addresses but with different port numbers. So that's it. I hope this lab video has been informative and interesting. So please subscribe, comment if you have any query on question or confusion, and share the video with others by supporting the channel. So let's see you in the next video. Welcome to the lab 13 STP, that is spanning tree protocol configuration. So in today's lab we will study and configure the spanning tree protocol, and these are the tasks that we will be performing in this lab. First of all, we will define the STP, that what is STP, why it is used. And then in the task 1, we will configure the host name of the switches and assign IP addresses to the PCs. In the task 2, we will check the default status of STP on all these switches. So remember, in the packet tracer, when you drag a switch from here and drop it over here, it has the STP protocol running. So in the default configuration, the STP is already enabled. So we will see the default setting, and we will identify the root bridge inside this lab topology. So there must be a root bridge in STP protocol setup. And in the task 3, then we will set a manual root bridge. So In the default STP setting, a root bridge is selected by the protocol, but we can manually select a switch to be the root bridge. So in this lab, we will configure the switch 1 as the root bridge. In the task 4, we will check the port roles of these switches. So there are multiple roles of the ports in the STP, such as the root port, the designated port, and the blocked or alternate port. We will study these a while. And in the task 5, we will check the connectivity between these PCs. For example, we will ping the PC2 and PC3 from PC1. And in the task 6 we will simulate a link failure. So here we can see in this topology, we have, if we want to, this PC1 is trying to reach PC3. This link is blocked due to STP, so it can reach via this way, switch 1 to switch 2 and switch 3. So we will simulate this link failure, the link between switch 1 and switch 2, and then STP will do its trick by enabling this alternate link. So we will see this, we will observe the STP convergence. And little bit about this topology. So we have these three switches, and we can see that a loop is formed between these switches, and the basic purpose of the STP is to prevent loops by blocking the alternate or redundant path. So here we can see that if PC1 wants to reach, let's suppose PC2, it have two paths. It can go via the switch 1 and switch 2, or switch 1, switch 3 and switch 2. So this is a type of loop. So what does STP do? That it disables a redundant path inside the topology, such as this fast Ethernet 02 port is blocked, so that there is only one path between the clients. So now let's start the task. First of all, what is STP? So STP is basically a layer 2 protocol that prevents loop inside Ethernet networks, and it does this by ensuring that there is only one path between the host or between the clients. So it dynamically blocks the redundant paths. We can see here this red dot shows that this path has been blocked by the STP automatically or dynamically. And then we have multiple terminology inside the STP, such as the root bridge. So the root bridge is the switch which has the lowest bridge ID. And the bridge ID is basically the combination of the priority. So each switch has the STP priority plus its MAC address. So if the priority of the switches are equal, then the lowest MAC address candidate switch becomes the root bridge. And then we have the bridge ID, as I told. So it is a unique identifier for each switch, which is the combination of priority value and MAC address. So the lowest bridge ID is the winner, or the you can say the winning point for the switch to become root bridge. So any bridge or any switch that have the lowest bridge ID is the root bridge. As I already told, it is a combination of priority value and the MAC address. So by default, all switches have same priority value, and then the switch having the lowest MAC address becomes the root bridge. You can manually set the priority value. So the lower the priority value, better the chance of becoming the root. So as we saw in the task 3, we will configure the priority value of switch 1 and make it the root bridge. Then we have the root port. The root port is basically on a non-root switch that has the lowest cost path to the root bridge. and it is only one port per switch. Then we have the designated port. It is the port on each network segment that provides the best path to the root bridge. It remains active and forwards the traffic. And then we have a block port, which is the port that do not forward the traffic and prevents loop, and such as this one, and it becomes active when the a path inside the network is disconnected or deleted. For example, we will see in this task 6 that we will delete this link, and we will see that this link will then become active. So the task 1 is to configure the host name and IP addresses of the species. So I have already done. I have configured the host name of the switches, as we can see, switch 1, and similarly for switch 2 and switch 3. And the next task is the task 2 is to check the default STP status on switches and identify the root bridge. So let's see this one by one. First of all, let's see in the switch 1. So to see the spanning tree status, we use the command show spanning tree. So here we can see that this is the priority that we are talking about. So this is the default priority 32769. It is the MAC address of the switch. So it is the cost, the port, which is basically telling us about the root ID and all the other information. And these are the port status. So these two ports, fast Ethernet 02 and 04, are in the designated state, while the fast Ethernet 01 is the root port that we already talked about. So this is the bridge ID. As we said, it is a combination of the priority value and the MAC address. So the lower the priority value, the better the chance of the switch to become root bridge. So this switch is not root bridge because we don't see any indication that says that it is a root bridge. So this one is not the root bridge. Let's go to the switch 2, and we will use the same command here. See the spanning tree status, and here we can see that this is the root bridge. So this switch 2 is the root bridge, and we will see in a bit that why it is root bridge, because the priority of all the switches is same. So the tiebreaker is basically the MAC address, and here we can see the root bridge does not have a root port. So all its port are a designated and forwarded state. Let me also check the switch 3, and we will again use the spanning tree protocol. So spanning tree, and here we can see the same information, the same priority. It has the address, and so this is not the MAC address of the switch, it is the MAC address of the root idea. You can say the root bridge. This is the bridge ID of this particular switch, and you can say that this is the MAC address of this switch. And its port are basically fast Ethernet 04 is in the designated forwarding state, fast Ethernet 02 is in the block state, alternate and block state. This one, fast Ethernet 02, it can be identified by this red dot, and the fast Ethernet 03 is the root port. So we have identified that the switch 2 is basically the root bridge. And why it is root bridge? Because its MAC address is lowest among these three. So to verify this, we will use the command to check the MAC address show version. So where this is basically the MAC address of the switch. So let me copy this. So this is the MAC address of switch 2. Now let me do the same for switch 1, show version, and its MAC address is this one. Let me do the same for switch 3, show version, and this is MAC address of switch 3. I'm just trying to show you people that how the root bridge is selected. So first of all, the priority, if priority is same, in this case priority is default and same, then the MAC address is selected as the tiebreaker. So here, how is the MAC address calculated? So we start from left to right and compare the MAC addresses octet by octet. So the first octet is 000, it is same. We will go to the second octet. Remember, these are in hexadecimal. So I have already calculated this. So this is not decimal 50, it is hexadecimal 50, then 60, then E0. And if you calculate it by converting this 50 from hexadecimal to decimal, similarly 60 and E0, you will come to know that this 50 is the lowest. So when you come to an octet where you find the lowest octet, then you stop and select the switch having the lowest octet. So in this particular case, switch 2 has the lowest MAC address, and that's why it is selected as the root bridge. I hope this is understood. So now we will go to the task 3, which is manually setting the root bridge. So this was by default. When you install the switch, it has the default priority, and then switch is root bridge is selected dynamically or automatically by the STP protocol, and the switch having the lowest MAC address is selected as the root bridge. So now we will configure the switch 1 as the root bridge manually. So I will go to the switch 1. I will go to the global configuration mode, and I will use this command spanning tree VLAN 1. So here we are using the default VLAN 1. In practical environment, we may have other VLANs such as VLAN 10 or VLAN 100, depending upon the environment. And the priority. So now I can choose a manual priority which should be lower than the default priority of 32769. So it says that the bridge priority is increments of 4096. So I am selecting this priority as the priority for switch 1, which is lower than the default priority of 32769, and hence it will become the root bridge. Exit, and let me save the configuration. And now let me give it some time, as we can see that the STP. So one of the shortcoming, you can say, or disadvantage of the spanning tree is that it is a little bit slow. Its convergence time is not very fast, it is slow. So we have other version of STP whose conversion times are fast. So now let me again see the spanning tree status. And now we can see that switch 1 has become the root bridge. So this one, the switch 1 has now become the root bridge because its priority is now lower than the default priority of 32769. And as I already told you that the root bridge does not have any root port. It basically has all the ports in the forwarding and designated states. And if you now the switch 3 fast Ethernet 03 port is basically in the blocking or alternate state. So now we one other thing that we can check is the port status. So let me again. So the ports are basically in three states. They can be in these three states: in the designated forwarding state, in the roots port can be a root port. So the root port is of non-root bridge, and in the alternate or blocking state. So only the alternate or block port does not forward traffic. The rest forwards traffic. And now let's test the connectivity. I have already configured the IP addresses of all the PCs. So I will ping the PC2 and PC3 from PC1 192.168.1.11. So this is PC2 IP and 12 is PC3 IP. So both these PCs are accessible. So the next important task is the testing the connectivity, which already did. The task 6 and the last task is simulating the link failure. So disconnect link between switch 1 and switch 2 and observe the STP converges. So now we will disable this link or disconnect this link, and when we remove this link, then automatically there will be, let's suppose if PC1 wants to reach PC2, since this link is no more available, it will come through this path. And since this port is blocked, the STP will unblock this port automatically. So let's simulate this. So I will delete this link. You can say, and now let me ping. It will take some time, but it will eventually activate this link. STP will automatically activate the link in a while. So again, let me ping PC2. So it is not pinging because the STP, as I already told, it takes a little bit time to converge. And at the end, we will see an advanced version of STP that is that has fast convergence. So it will take a little bit, and I think it is converged because we can see here the link is now active, and we can see that PC2 is now accessible. You can also ping the PC3, it will also be accessible. So as I told you in our discussion that STP has low convergence. So what we can do that we can configure another STP protocol, which is rapid PVST plus. So we can do this by using the command spanning tree mode rapid PVST. So let me enable this command on all switches. Which one? Spanning tree mode rapid, and let me do the same on this switch 3. Spanning mode rapid. So now if I check the spanning tree status, so we should have this newer version, and here we can see that spanning tree enable protocol is RSTP. RSTP basically stands for Rapid Spanning Tree Protocol. So it has basically fast convergence time. So let me connect this link again, and let us see that is there any improvement. Let me connect both these to fast Ethernet 0, 1. So as we can see that it is really fast as compared to the STP. Let me do this again. Disconnect this link and let's see that how fast. Oh, it is really fast as compared to STP. So that's it, friends, for this video. I hope it has been informative. So please subscribe, like, and share the video to support the channel. And we'll see you in the next video.